Let me also, before I forget, tell you that a very common practice in industry is hydrostatic testing. What does it mean? You know that more than 98% of pipelines used in pipeline industry, in oil and gas industries, are basically welded pipelines, ERW. When they weld the pipe, then if the internal pressure of the fluid later to be used or later to be carried through the pipe is 60 psi or less, they use a test they call as it is called pneumatic test. It means that you apply gas or air and to find out if there is a leakage or no. If the internal pressure of the fluid to be passed later is above 60 psi, which is something that quite happens, then they use hydrostatic testing. It means that they put water into the pipe, apply pressure, normally 1.1 times the actual maximum pressure, and then they see if there is a leakage or not. The main difference between pneumatic testing and hydrostatic testing is that pneumatic testing is just a leakage test. Hydrostatic testing is a leakage plus a strength test, okay? Now, when they put this water inside the pipe, then after the test is over, you have to drain and dry the pipe. In reality, this does not happen 110%. You still have water pockets left in the pipe. And because most of the time, the water used to carry out hydrotest is coming from seawater or well water, such natural sources of water, and they are not treated with biocides, etc., they have an active collection of corrosion-related bacteria. And these bacteria mostly prefer to corrode the heat-affected zone. Why? Because during welding, when you put heat into the metal, you actually create a gradient of molten metal where the alloying elements from the parent material will be flowing towards the heat-affected zone. Therefore, that region is quite rich in alloying elements that can be later used by bacteria as their food. That's why they all flow towards that region. And from welding engineering, we know that the heat-affected zone, the welding zone, is a restless area. It is like a wound in the body. Therefore, after hydrostatic testing, or even during hydrostatic testing, many cases of failure happens. I have been involved in several cases as such. I have explained them in my book about hydrostatic testing and microbial corrosion. And the reason is simply because there are several corrosion scenarios that can be expected there, but the most probable one is microbial corrosion. And therefore, when you do hydrostatic testing, even if you are fully successful in draining a good part of the water, the bacteria that are left behind, it is very interesting. The bacteria that are left behind, they go on fasting. They reduce their size, they reduce their energy requirements. So they just stay there till you put a fluid like gas, oil, water, whatever, into the pipe. Then they find an unlimited source of food, and therefore you will get internal heating from such cases. This is a very simplified picture of what can happen as a result of hydrostatic testing. Just imagine if the site supervisor, if the operators, they know about it, then they will at least consult with someone who has the experience and then try to minimize the possibility of risk.
Right. That's really enlightening, because cathodic protection, hydrotesting, smart pigging, stainless steel, these are such standard practices in industry that
Yes.
nobody really thinks about them twice before applying
No,
them. They usually
that's right.
have standard procedures and they'll just follow it. So to
That's right.
know that they may not be, should I say, they may not be smart enough for MIC is really,
Yes.
I mean, I find it very interesting.